is titled More Geometric Proofs. It's on pages 8 and 9, and we're going to answer the question, what else can I prove? So question number 46 is, what else can congruent triangles tell us? Your task is for each statement below to construct a convincing argument that is true. You're going to organize each argument in a 2-column proof. You're going to clearly state what are proving and include what you are proving and include a diagram. Be prepared to share your proofs with the class. For part A, they want us to prove the diagonals of a rhombus that they bisect each other. That is, prove for this very specific figure that angle ABD is congruent to angle CBD. Okay, what you're going to notice is that some of the information is filled in for you, and some of the information is missing. Okay. The one thing they do tell us is that ABCD is a rhombus. So that information is given to you. Usually your first statement is given, sometimes even your second statement is given if they give you 2 pieces of information, but not always. Okay? By definition of a rhombus, we're going to mark segment AB congruent to segment CB. So on AB, I put a little tick mark, and on CB, I put a little tick mark. That's because the definition of rhombus tells us that they are congruent. Okay? That gives us a side on one triangle congruent to a side on the other triangle. Okay? So if we need to prove these 2 triangles congruent, we need it either to be by side, 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 angle, 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 side, or hypotenuse leg. Okay? Then we're going to note that DB is congruent to BD. That's the shared side right there in the middle, and it's congruent to itself. Sometimes that is called the reflexive property. A lot of people refer to it as shared side. You can just write either shared side. They wrote it as the segment is congruent to itself. It's part of the top triangle and part of the bottom triangle. Okay? So it counts as 2. So that is our second side from each of the triangles. And then we have DA congruent to DC. So I triple ticked that one and triple ticked that one. That is also by the definition of a rhombus. Consecutive sides are congruent, and that gives us a third side. Once you have a third side, you can say that the 2 triangles are congruent to each other, and the theorem that we used is side, side, side congruence. Okay? Once you've proven that the 2 triangles are congruent to each other, then their corresponding parts will be congruent to each other. So angle ABD, which is right here, is congruent to triangle CBD, which is right here, are congruent to each other. This is CPCTC. Corresponding parts of congruent triangles are congruent. Page 9, we have part B, which says, in chapter 2, you used congruent triangles to prove that if a triangle is isosceles, then its base angles must be congruent. Write the converse of this statement. How can you prove it? Assume that angle E is congruent to angle G, and in the diagram at right, add an auxiliary line so that you can use 2 congruent triangles to prove that the triangles must be isosceles. Okay? So over at the right, they're having us dash in a line. That's called an auxiliary line. So we draw it from F going straight down angle like that, it creates two congruent angles. So you're going to want to show a tick mark on those angles to show that they're congruent. So the first statement is that FM bisects angle EFG. That's what we just drew in. And point M lies on FG. This is what they told us to do. It wasn't given, but it's just a line that we drew in. Okay? They did give us that angle E was congruent to angle G. That was given right here. Okay? And that gives us an angle from the triangle on the left, congruent to the angle on the triangle on the right. So we have an A. Okay? Then for statement number 3, we have angle EFM congruent to angle GFM. That's the one I had you mark congruent to the other one up here. That's the definition of an angle bisector. If you bisect an angle, bi means cut it in half and create two congruent angles. Okay? That gives us another A. So we have angle so far. For step number 4, we have FM congruent to FM. That's reflexive. It's that segment right down the middle. It's part of the triangle on the left, and it's part of the triangle on the right. So that counts as our side. Okay? Once you have 3 things congruent, and it's one of our 5 triangle congruents, you can say that the 2 triangles are congruent to each other. And then for the reason, you would just have to say which of the 5 triangle congruents that it is. Okay? It's the angle side. I know that because I wrote angle side. I just kept track of it as I went along. Okay? Statement number 6 says EF is congruent to GF. So this side over here ends up being congruent to this side by CPCTC. Corresponding parts of congruent triangles are congruent. And triangle EFG ends up being isosceles based on the definition of an isosceles triangle. Okay? You just need to have 2 sides congruent. All right. Question C, down at the bottom. You're going to do in groups of 4. The directions say, what can congruent triangles tell you about the diagonals of a rectangle? Using the fact that the opposite sides of a rectangle are parallel, which you proved back in 7-7, prove that the diagonals of a rectangle are congruent. Okay, so it's going to walk you through the steps. You're going to either fill in the missing reason or the missing statement. You're going to do that in your groups of 4. Make sure you mark pieces that are congruent. And if you get stuck, raise your hand and I'll come around and help you in your group.